All right, this is live teaching in class. And so again, we're going to do the same steps we did in the previous video. We are going to take this standard form and we're going to rewrite it in vertex form at just a little bit quicker pace. First, I'm going to take the constant and move it over to the left-hand side. Notice this is a -1. At any time that leading coefficient is anything other than a +1, I must factor it out. How do I do that? So I'm going to put a -1 with parentheses behind it. Then I'm going to ask myself, -1 times what value is -1? Bring down the x squared. -1 times what value is -2? +2. And as I spoke about in the previous video, this is always plus, and we're going to fill that in shortly. I'm going to focus in right now on the trinomial that is in parentheses. I'm specifically looking at the b value with the sign included. We're always going to take that b value, divide it by 2, and square it. Well, 2 divided by 2 is 1, include the symbol, and 1 squared is 1. This is trickier than you think. I did not add a value of 1 to the right. I actually added a value of -1. So to keep the equation balanced, if I added -1 to the right, I must also include a -1 on the left. I combine like terms to now have y subtract 6 on the left. And on the right, there's a quick way here to factor this trinomial. We put an x in front and drop, in this case, a +1. We're going to add 6 back to the other side, and I have y equals -1 times the quantity x plus 1 squared plus 6. Now, I believe that this is correct. Like, everything's looking great, but you must verify. This is the step where you verify. So if everybody can take their calculators, and we're going to plug in -x squared, subtract 2x plus 5. And then down below will be -1 times x plus 1 squared. Okay, and I'm verifying that one is directly on top of the other. Now, you may be thinking, because students have mentioned this before, how do I know if they do not line up? As I showed you in the previous video, I'm just going to change this into a subtraction quick so we could see. You would see the two functions in different colors on your calculator, and they would not be on top of each other. That is not the case here. I was just demonstrating that. Next up, we can very quickly identify the vertex and the y-intercept. The vertex for this, it lies to us, and it tells us the truth. -1, 6. The y-intercept will always come from the standard form, the constant in the standard form. So 0, 5. Those that are in class with me, you're going to raise your hand high on if you have a preference. Who prefers to use the quadratic formula now to find the x-intercepts? Go for it. That's no problem. Who prefers to use the vertex method and replace y with 0? Hands up high. So you choose a method right now. I'm going to give you a little head start. You choose whatever method you want to use. I personally think it's easier for me to take the vertex method and replace y with 0. Either method works. I'm doing PEMDAS backwards. So on the side that contains the variable, I'm asking outside the parentheses, is there any adding or subtracting? There is. Opposite of adding is subtracting. Is there any multiplier or dividing on the side that has the variable? There is. Dividing by -1. Is there any exponents? Again, there is. And this tells me I'm going to have 2 answers. And lastly, when we take away the parentheses, how do we isolate? We're going to subtract 1, and whatever comes over last is going to stay in front. Now, what do we do next? We have to verify again. So I take my calculator, going second, calculate value, and I am checking right now. How do I know? Because when I plug it in, press enter, y has to equal 0. Checking both of them, and we can see they both work. What I don't want you to do is say, this is the x-intercept, because the standard says mathematically you must show me using algebra. The last thing I'm going to do is I'm going to now graph this. using what you learned in the previous unit. So I'm going to start with a vertex of negative 1, 6. So I'm right there. I'm going to write down negative 2, negative 1, 0, 1, and 2. Those will always be used as my point for the parent function of quadratics. Now, directly in front in vertex form is a negative 1. I've used this to find the vertex. I'll take the negative 1 and multiply it by the y's. Becomes negative 4, negative 1, negative 4. How does this help me? Here's 0, 0. I'm going to go right 1 and down 1, and left 1 and down 1. From the vertex, I'm going to go right 2 down 4 and left 2 down 4. And we've completed this problem.